All right. This is the intent of our research efforts. It's a little grandiose. That's the point. The intent of behavioral research is to provide definitive results about causal relationships between behavioral constructs so the results can be broadly applied. Now, when you say that, you're thinking, yeah, that's what I want to do. That's what I want my research to do. There's some variability in whether you're a more focused on theoretical or focused on applied, but nobody minds having the stuff they work so hard on be helpful and useful for people. In academics, there's a couple of standards, one of which is getting your shit into an intro text. There's something magical and special about tens of thousands of intro psych students or comm studies or poly or whatever reading your shit. Don't be embarrassed by that. So here's the thing. There's 4 parts of this that we're going to quarrel about a little bit. We're going to talk about what it means to set these goals. Definitive results, causal relationships, constructs, and broadly applied. Let's take a look. So definitive results, behavioral research. Now, the research we're talking about in here is empirical, quantitative research methods and data analysis. We are limited to that. Once again, I will never say anything negative about qualitative research. I had an opportunity to study with people who were developing this back in the 70s. It was cool. Cresswell and I have an interesting relationship when he was here doing qualitative research, because he would call me up and say, some of your students are coming over here and I'm pretty sure they don't really want to learn qualitative research. They're just learning how to collect data, and I know they're coding it and putting it in SPSS. I said, yeah, we are. I sent them to you. Thanks. 10 years later, we have mixed methods. That's all I'm going to say. We work very hard to be sure that those data are representative, but they are always incomplete. Remember we talked about representation and inference? That's what we do. That representation is always insufficient, and so our results are never complete. And then we take this incomplete, not perfectly representative data, and we run it through statistical models. The results from the statistical analyses are probabilistic rather than exact. We all know 0.05, but look what... Oh, sorry, let me turn this off. I don't know who you are. Oh, I know who that is, but no. If the null hypothesis were true, that the populations represented by the sample have the same mean DV value, then we would expect to find a statistical value this large or larger less than 5% of the time by chance alone. Thus, we conclude that it is unlikely the populations have the same mean DV value. All of that is captured in P, left pointy, 0.05. We'll talk more about pointies later. That's it. Now, the big word in here for all of this magical stuff, is conclude. We conclude. We do not prove. We conclude. We decide. And when we talk more about p-values, we'll talk more about deciding. Causal relationships. We would love to know what things cause other things. We would love to. It's part of the human condition, and I say that because causal inference is not only through science, but it's through poetry, literature, music. It can be implied by looking at statuary, hieroglyphics. You can't turn around without bumping into people saying, A causes B. I'm just sure. Well, we have to do better than I'm just sure. We have to create methodology that allows other people to be sure that our sureness is right. The evidence you need to say there's a causal relationship, you might as well start memorizing this now. Write it backwards on your forehead. That way you see it every time you brush your teeth. My wife, the dentist, would say, brush often. Temporal precedence. Cause comes before effect. I don't want to have a conversation about particle physics, okay? I had some of that coursework. It's absolutely true. That's not what we're talking about. Statistical relationship, because if two things aren't related, it's tough for one to cause the other. And then the booger, the absolute pain in the ass. No alternative causes of the effect, no confounds. That when I say A causes B, I have created a situation in which A precedes B, shown that A and B are statistically related, and also created a situation in which there is no D, E, F, or G. That's all we got to do. The mainstay for this is true experiments, but one of the distinctions that we will make is that a true experiment is defined by process, not result. So running a true experiment in our lexicon is not a guarantee of causal interpretability. We have a whole list of shit that can go wrong. We'll go over it carefully, not today. Random assignment, manipulation controlled by the researcher, and then the magic dot. Systematic control of potential confounds. Just A and B in the world. That's the right face, by the way. That is exactly. She's looking at me like, uh-huh. Not with my variables. Absolutely. However, true experiments can't always be performed. Some causes simply can't be randomly assigned and manipulated. I will use the word poofed because it's funny. To poof something means to have absolute control over it in my experimental setting. I can poof number of practices. I can poof which instructions you get. I cannot poof anything about you or your history. Okay, so poof, funny word, drives home the point. Can you really flip a coin and then do what that coin says? Here, you are now a member of this population. Ethics, there's some stuff we can do that we've decided not to. And cost, this is particularly annoying for graduate students. We could. Hell, I can approach the equipment that would allow me to do it. And I'm allowed, but I don't have the resources. I don't know if anybody did this intentionally, but one of the great things about graduate school is you learn how to find the second best way of doing things. And you look at a couple of different second and third best and see if they converge. Because if they converge, it not only gives you confidence in them, but it gives you confidence in the best. Very often we discover that the best is only the coolest and not actually the best. Behavioral constructs. Unlike physical attributes often studied in the hard sciences, lots of quotes, mass, velocity, and pressure, most of the attributes we study are constructs. That is, variables that we have made up in order to help organize and explain human behavior. Now let's be honest for a second. I don't know what your exposure to hard sciences is, but most of the hard sciences have given up directly measurable concepts a long time ago. Things are second and third order represented. It started with cloud chambers in the 30s and the 40s. And so this idea that they're magical because they touch all of their variables and we kind of suck because we're making stuff up is wrong. The purpose of a construct is hopefully to represent, the intent of a variable or a measure or an index or an instrument is to be able to measure a construct well enough that when we measure multiple constructs and look at how they're related to each other, we're learning something useful. That's why later today we will talk about how important attributive hypotheses are. So we want our data to be construct values, but we're limited to variable scores. Often our variables aren't direct, but dependent upon self-report, complex behavioral or content coding schemes. God bless qualitative researchers. The quality of our measures is important. Results can be broadly applied. Come on in. We want our results and conclusions to be meaningful and applicable, either to theory or to practice. But in order to conduct our studies, to get our data, we make choices that can limit the meaningfulness and applicability of the results from the analyses of those data. We're going to talk about methodology as art and craft of science. The reason I call it art and craft is like other arts and other crafts, it's all a bunch of decisions that are made. When an artist or a craftsperson approaches something they're doing, they are constantly making decisions. That's what we do. Those decisions have to be based on knowing the best practices of our research community. Like having read the method section of the last 40 articles, so we know, almost everybody in my group does it this way. Now, you are never going to hear me say not to go to war. about methodology, about measurement, about analysis. What I will strongly encourage is that when you go to war, you know you're going to war, and you know what you're going to war with. We'll tell stories as we go. So the idea is that different combinations of the choices we make, samples, location, tasks, stimuli, manipulations, and measures, can produce different results. If we're going to worry about a replication crisis, we first have to worry about a replicating crisis. Now here's the cool thing, and this is the first real part of our taxonomy. Every one of these relates to a kind of validity. The validity language is the language you use after you say, I like this study or I don't like this study. When someone says, oh, you don't? Why? Anybody. All right? You got to look good after you cast your ballot. Everything you say about the quality of a research study wedges into one of these four. This is the language of quality, language of validity, language of evaluation. So we've got four basic kinds. And this is all you're getting, and I'm sending you off to a pink thing. Because the pink thing is just practice with words, synonym structures. What words herald what? And let me tell you about the pink things. The pink things vary from really well written, easy to tell what the hell Cal's talking about. I can pick this one, and when I miss it and you show me the right answer, I do this. Which is okay. There's going to be a lot of this. Oh, wait till we get to SPSS. There are no clever mistakes in SPSS. They're all like, yeah. But some of the pink things are kind of sucky. And those are the ones that I copied out of articles and textbooks. Because we're not really good about writing everything to each other. We're not really good about really being clear. I want you to be better at this, and so I'm going to herd you into it by a combination of really clearly written stuff and stuff that if only it were written this way, it would have been clear. Measurement validity. Do our variables and data accurately represent the behaviors and characteristics we intend to study? This is the one we're going to spend the least time on, but it is arguably the most important, and when you do research to try and figure out why people do and don't read articles, the number one reason that people do and don't read articles is whether they like the way the variables were measured. Who did it, where they did it, how they did it, design, statistical analysis. All of that stuff pales in comparison to, oh, I don't care about the way they measured this. And there's a huge interaction between sort of level of training from first intro stats class to journal editor, several layers in there, and how important measurement is. And the point is that measurement validity is more important to the levels that are evaluating and producing the research. External validity. To what extent can our results be accurately generalized to other participant situations and times? That's a good formal definition. Here's mine. What have we learned and how far can we push it? What have we actually sampled? And remember, we're going to have a broader definition of sample than who. Who, what, where, when, and how. Who have we actually learned about? Where are they? Doing what? When? What have we actually learned? And then, how far can we push it? Now, obviously, the how far we can push it part is dependent on our knowledge of the literature and an agreement of how far we're going to push it. Different research communities that snug up against different applications and practice communities have frighteningly different opinions about how far you can push what. Some will not cross the line from animal to non-animal research. Others are pretty much uninterested in the shape or species of where the data came from because that behavior or characteristics pretty important, so much so that we'll generalize across it. That sounds like it's complicated. And always our way of solving complexity is break things down into categories and then take those categories back to our parent literature of our research community and know what our research community expects. What are best practices? And remember, I'll never tell you don't go to war. Sometimes we have to change shit. Internal validity. The typical definition of internal validity is about causal interpretability. Do we have enough internal validity? Do we have enough control over the situation that we can causally interpret things? Now on Monday, I'm going to change that up a little bit. I want you to worry about internal validity, whether you're testing causal hypotheses or other kinds. Because here's my bold claim. Confounds change results. And confounds change results whether you're going to give those results an associative hypothesis interpretation or a causal hypothesis interpretation. Extra shit floating around in the data changes the data. And variables C, D, E, and F may change the apparent relationship between A and B. That's what the spring is all about. The spring is all about being able to look beyond the relationship between A and B and take C, D, E, and F into account statistically. Right now, we're pretty much dependent on our design to clean stuff up. So we have to be able to look at a design and decide if we think it's clean or not, according to the standards of our research community.
Dr. Cal, doesn't measurement validity and internal validity represent the same thing, basically?
Oh, hell no. You can have a really, really good manipulation of number of practices. Okay? I can make absolutely sure these people get 1 and these people get 10 after random assignment. Okay? Now, if I'm not paying attention and the people in the first condition sneak in a couple more, that's a measurement problem. I'm splitting a hair here on purpose. That's a measurement problem. But if the people in this condition want to take longer to reread the instructions and do the task, that's not a property of the measurement of the independent variable. That's a confounding of procedure. You with me?
Okay, so I understand it like measurement is more with, internal validity is more with respect to how am I controlling my experiment.
Yep.
Measurement is how am I measuring my behaviors.
That's right. Where do the numbers come from? What's going on while I'm getting the numbers? For example, again, I can stand there and make sure they do it once and they do it 10 times. But if everybody in here is experienced with the task, and everybody here has never seen the task before, that internal validity problem has nothing to do with the measurement. Now, I understand I'm splitting hairs. That's what we do. Okay? So keep asking those questions. Statistical conclusion validity. When it's all said and done, and we have gotten our data, taken our data, analyzed our data, and say, oh, found shit. Are we right? Now, here's one of my favorite slides. I love this slide. Statistical conclusion validity is what we really give a shit, I will claim. We want our results to be right. And here's the thing. As data analysts, as theorists and practitioners, we have a broader definition of statistical conclusion validity and its causes than a straight-up statistician. To a straight-up, hardcore statistician who's not working with real data, where they come from and what they represent, but is talking with what the statistical models do as math and as a tool. The fundamental source of statistical conclusion problems is chance. Sampling variability. Or in the technical language of statisticians, shit happens. But to us, notice the arrows are important. Statistical conclusion validity is driven not only by chance, but by external, internal, and measurement validity. It's not real hard. If you're measuring your variables badly, might you get the wrong results? Yep. If you've grabbed a sample that doesn't represent your population, might you get the wrong results? Yes. And as I've already said, confounds change results. How are we doing? Live this slide. Sir!
We had problems with any of the other three. Is it safe to say that we always have problems with them?
That's what I'm claiming. That certainly that's the way we want to think. That's the way we want to set high standards. That to really believe the results that we got We have to really believe how we measured, how we sampled, how we controlled, and the chances on our side. We'll do more with all of these, I promise. What I'm trying to do today is I'm trying to get you to think about statistics like a data analyst, not like a statistician. And we will see lots of other times where the people who make the tools and the people who use the tools look askance at each other. Yes?
How do you control for confound in an area that has been researched?
There's two choices. Quit and start banging on it. You're absolutely right. When I say we go back to our research community's literature to know what our best practices, we sometimes get back there and go, these don't help. So sometimes you have to slide over. Very often there's some aspect of what is new to us that's not new to somebody else, and you go dig it out. Behavioral scientists are the best or the worst, depending upon how you think about it, at this. Psychologists will borrow from anybody. I'm not going to make any aspersions about the rest of you, but I could. You go and you borrow stuff, you steal stuff, and when you're doing it, you're worried whether bringing it over is a really good idea. But it's something, somewhere to start. And we're going to give you the complete answer to your question in about 12 slides. Yes?
So I'm starting a little bit with how external validity affects inclusion validity.
Sure.
I feel like I get the other two
Okay.
as well. But I feel like, as I've understood external validity, it's how your conclusions can be extrapolated beyond.
Absolutely.
Like,
That's
outside of, right?
That's the usual.
So how is it that external validity can affect your statistical conclusion validity as opposed to the other way around?
Gotcha. So here you go. Before I say, and how far can we generalize it? When I talk about external validity, I say, what have we learned? So, you tell me that you want to study third graders. Like, I like third graders. Go study third graders. You don't have enough third graders. So in addition to the 50 third graders, when you promised me 100, you get 25 second graders and 25 fourth graders. Now they're third grade on average. But they're not really the population you went after. And that group might not be representative of the third graders you were claiming all along. The conclusion you get might not really be about third graders, but about mixed grades.
Right, okay.
That's all I mean.
Thank you.
Sure. Then you get into fun things like, well, you know, you're looking at a test that's specific to third graders and you gave it to second and fourth graders. What the hell are you doing? Now we've got a measurement problem driven by an external validity failure, and sure as hell that could change things.
Right.
Remember, all we're talking about here is change that then becomes inaccuracy. When we say, this is who I studied, how, what, where, and when, this is what I found, as long as that description is cool, that's cool. It's when you say, I did third graders with a standardized third grade measure, and you actually did other people. How are we doing? Confounds change results, samplings change results, measures change results. Changed results might not be right.
So like the math should be correct,
Well, hell yeah.
but the correct math doesn't matter if the other validity.
Doesn't matter is a little tough because we never really get to do what we want to do, so we're always behind. That's why I say, how far can we push it? Not right or wrong. So this whole wait, Marvin.